Okay, so just a quick introduction to myself. If you haven't met me before, I'm part of the Symmetry manufacturing team. I've been consulting now with the team for over 10 years. So I'm based in Scotland, if you can't tell with the Scottish accent. Being with the company for 10 years means that I've probably passed through quite a lot of the solutions that we offer. And those solutions are based around Symmetry tech as well as Autodesk solutions, mostly based around manufacturing, and most recently based around advanced manufacturing and simulation. So in the past, I've been part of a mechanical design engineering team based in Aberdeen, working mostly in oil and gas. So today's subject is quite close to me in terms of how I've actually worked with design departments, and I've got a good idea of the bottlenecks that can arise during the time between different phases of design, and therefore I do have quite a lot of experience of how these things can become larger scale issues as they kind of get promoted down the design process. So let's move on from there and think about what SimSolid is as a product. Now, just to give you a bit of background again, just quickly on the relationship with Altair. Now, we've been promoting solutions from Autodesk for such a long time when it came to simulation, and thankfully Wazim introduced the Altair products to us. We've been working with Altair now for several years, working towards the same goalposts, and it's been an interesting few years picking up the products. Now, SimSolid was the first product that I seen from the Altair range, and without looking at any of the other products, that one product was interesting for me because I wanted to know how quickly it could give me results. And so therefore, that's the product for me that stands out for design and engineering. And because of its fast-paced kind of a process, and the results are, immediately presented to you with accuracy, this type of working is quite alien when you think about simulation, because we're so used to a very traditional workflow, which can cause problems where we spend a lot of time in areas and we need to refine a lot of geometry. Now, SimSolid empowers design and engineering to bring in that fully featured CAD into the environment without any compromise on your design. Now, again, if you see my LinkedIn post, I talked about it being wizardry. Now, a lot of people ask the question, so what is it doing? So I'm going to try to give you as much information over the next 45 minutes to help enlighten you on what the product is actually doing. Now, there will be some handouts that you'll see, and there'll be some links as well to some videos. So all of the information is open source for you to go and to find out more about these products, but also we're here to support you. But it is a very good product in terms of eliminating the time from your more traditional simulation processes. So what are the 5 key benefits of the use of SimSolid? Now, the first one is understanding your design, and that's more based around super quick, build process where you can have design iterations and analyse without refining any other load case. We simplify the CAD and understand the design in the first phase. So that's one of the key benefits. Now, it's very user-friendly. The user interface is very minimal. It allows you to work through the process where you bring in the model, add the material, create your case loads, create your results, reiterate if need be. It really is very quick, and you'll see that when we get into the demonstration. Oh, I went too far. The most important one, and I skipped through it really quickly. So it's meshless, it's a meshless technology. And this is where the wizardry comes, and a lot of people ask questions about how the geometry is interpreted within the system. Now, like I say, I'll go over it in a bit more detail, but there are white papers and there are also video content that we can supply to you so that you've got complete access to how the product deals with your geometry. So it's a multi-analysis type software, which means that it's capable of linear, non-linear dynamics, fatigue, thermal. We'll look at a slide specifically that explains all of the analysis types that you can produce within the software. But it is very high end. Even though it does work through the process very quickly, it can produce very accurate results in that short time. Okay, so we're going to jump into the first stage, which is the geometry import. So I'm going to import in a model from my folder on Windows. Now, there's various types of file format that we can use within SimSolid, and this drop down here indicates the types of files that we tend to bring in. We can work with parasolids, we can work with step files, SolidWorks files, Inventor files, lots of different file formats. Today we're going to work with parasolid files. So I'm going to import in the geometry. Now, the first thing that tends to come up inside SimSolid is this automatic creation of the connections. Now, just to go through a few different things with you, I'm actually going to cancel the dialog box just to give you an idea of other things within the software. So what we're going to do here is we're going to take a look at, sorry, just give me 1 second. That's better. Okay, so we're going to take a look at this this model here today, and it's 2 beams which are set up on top of another structure with some bolted connections, and we're going to apply some loads and we're going to apply some constraints, and we're going to look at the analysis. But before we do that, we're going to just take a look at some of the interface to give you an idea of how that works. Now, we do have the ability to work with things like graphical interpretation of the model. Whenever you're working, it's important for you to work in such a way where you can see the geometry. Now, if you want an outline and things like that, we've got some options in the ribbon here where we can use some views, where we can look at front, back, left, right, these types of things, allowing you to view the model in such a way. If you quickly seen, there was mouse controls that allow you to work with a specific CAD application that allow you to change the way that the mouse works within the software. Over in the left-hand side here, we've got the assembly. Now, when the assembly comes in, it's automatic. So what it does is it recognises the geometry based on the criteria. So we've got some assembly components which have been placed into a type of washer, into a type of bolt, and then we've got some geometry at the bottom here which is based as the generic type of geometry. So when you click on the tree, you get different icons down the left hand side here depending on what you're actively inside. Now we can do something like review the parts. These are nice checks here where we can review some of the parts within the geometry. We can do things like check the geometry for any defects. So whenever you're working with someone else's geometry, there might be an instance where there's a defect within the model that you're not completely aware of. So you can see that you can come in here and we can do things like look at the facets and any overlapping geometry. Now, there's none in this instance, but we do have these types of checks that we can use. We can also look for any problems with groups and things like that as well. So when we are ready for the next stage, what we would tend to do is we would look to look at the types of analysis. So we can see that we've got structural analysis, modal analysis, dynamics, and thermal within the software. We can see that if we select the assembly, we've got some icons that represent the material. So we can apply a material. So we'll click in there to apply material just now. There's a material database which is applied in the background of SimSolid, where we can do selection of generic materials or create our own. So I'm just going to apply it to all of the parts. Once we've applied a material, the way that we would double check the material's been added is to look back into the project tree, and you can see next to each of the components we've got the tab that indicates that the material that's applied is steel. Okay, so we're just going to jump back into the presentation quickly. So within the geometry import, we brought in the existing CAD model. We used automatic feature recognition where it recognised the nuts, the bolts, and the geometry that we brought in. And we also seen the ability to work with some checks, so we can check the geometry. So the next stage of the process would be to build connections. So we jump back into SimSolid and we go back and click on the project tree here. It will give us access to the different types of connections. Now, we're going to be working with automatic connections, but we do have the option for manual connections. We also have the option for things like welds, where we've got spot and laser welds and seam welds. We do have the option for adhesives, and we also have virtual connectors, where we've got pins, bushings, rivets, joints. Okay, we can also do things like show any disconnected parts by groups. But you can see here that it's telling us there's 37 disconnected parts, but that's because we don't have any connections in there just now. Okay, so we can close that off just now. So we're going to run the connection dialog. Now, when you bring the geometry in from the beginning, as you've seen before, you would have been presented with this automatically. If you're working with weldments, it's a slightly different approach. You would add the welds and then do the connections. But in this instance here, we can use the connections as they are. So we place in a gap and a penetration. Now the gap can be the gap between each of the components. If you know the model well, you might already know what that distance is. The penetration would be any components that you know of that are penetrating through and what distance it could be possibly penetrating through. Now we can run this dialog box multiple times to achieve what we're looking for within the connection types. We also have the ability to change the resolution level. If you think about maybe changing the resolution level on any components that you've got that are circular with a flat component on top, you might only get a slight connection, and you might want to increase the resolution level there so that you get more of a connection over some sort of like tangent connection where you've got that kind of cylindrical shape with a flat plate on top of it or something. So in this instance, we're just going to go with the defaults, apply the connections. When the connections come in, they fall into two different folder types. You've got fastener connections, and then you've got regular connections. Now, the fastener connections are quite important. This is the main reason why we would use SimSolid. and because it recognises the different types of connection. So if I zoom in and select one of these connections, you can see here that it's added some bonded connections and sliding connections automatically. And it'll have done that for each of the connectors all over the assembly. Okay, so that's one of the biggest benefits of using SimSolid, is the fact that it applies those connections for you automatically. Okay, and we do also have the checks, like I say, if you've got any problems with the connections as well. You can see that you can go in and use the connection checks to find out if you've got any problems. Okay, so we're going to just jump back to the presentation just to have a quick review. So connect the models, we're going to validate the model and the extensive connector library, the different types of connectors, which I'll go back in and show you, which I just forgotten to do, but I'll go back in and show you that. So the next stage would be to look at the setup of the study. So just before we click on the setup of the study, I just want to double check actually, because I think Jess, can you still see my screen?
I can still see your screen.
Thank you. Just give me 1 second. Too many screens. Too many screens. Okay, so we're back to SimSolid. So on the connections, we can see that we've got the different types of connection that we went through. Just to remind you, these are the drop downs for the different types of connections. Now, when we're ready to run the study, we can see that in the drop down list in the ribbon as well, we do have access to the different styles of study analysis that we want to run. So the study that we're going to run in this instance is a structural linear. You can see that it's added to the project tree, and within that we get access to these different icons that represent our loads and our constraints. So what we're going to do here is we're going to add an immovable support, which is our fixed constraint to each end of these beams here and here. So all we're doing here is we're selecting the face. So I'm just going to zoom in. We're just selecting the faces. Just going to move the model around and select from the other end as well. And once we're done, we can click OK. Now, if you want to see those boundary conditions, then we can use this icon here, which allows us to see the boundary conditions applied as well. And when we add things, it gets added to the project tree. We can completely edit those, delete them, rename them, modify them. So then from here, we've got the different styles. So these are the different styles of supports. So we've got slider supports, we've got hinge supports, spring supports, and any alignments. And then we've got our pressure, force displacements, gravity, inertia, remote loads and displacements, thermal loads, bearing loads, distributed mass. We've got our bolt and nut tightening, which we're going to go over. And then we've got our volume and expansion and shrinkage as well. Okay, so the next thing we're going to do is we're going to add a force. So I'm going to go into the force displacement, open it up, and I'm going to add it to these internal faces here. So we're basically supporting the beam at either end, applying a force in the minus y. And you can see here, this corresponds with the coordinate system on the bottom right hand corner. So we're applying the value and we can click OK on that. So again, with the boundary conditions viewed, we can see here that we can see everything that's been applied by us. And on the left-hand side, we can also see that we've got our immovable support and our force displacement, which is completely editable. So one of the other things that we can do within SimSolid is we can add our torque to our nuts. So what we can do here is, if we use this icon here, which allows us to add that tightening, then we can highlight the model, which will allow us to pick all of the nuts. You can see here that they've all been picked up within that selection, and then we can walk through the input in the dialog box. Now, if we apply the pitch, we then have 3 options for the tightening: number of turns, torque, and the target axial force. Now, in this instance, we're going to pick the torque, and we're going to apply the tightening to each of those. Now, you can see the icons applied to the model, and these are all based on the boundary. Okay, and now that we've done that, we've got our structural. We've applied our loads and constraints. You can see them here in the tree. And the next thing we're going to do is we're just going to run the analysis. Okay, so we're just going to jump back in to reiterate. So we ran the study. So we created the constraints and loads. We added the preload, and we looked at the specific contacts. So the next stage of that process would be the analysis and the results. So from here, you can see we now have this indication which allows us to run the analysis. If we have any problems with the model, if there's not a material added, if we haven't took that process through each stage, then we'll see warnings that pop up. The software will tell you if there's any problems, you haven't applied a material, you haven't done something. It's quite intuitive. So if we click on Run to run the results, you can see that when the results are complete, you'll get access to the results in the project tree, and you'll also gain access to some more icons that are displayed below the results on the right-hand side. So from here, we can go in and look at displacement. If we take the boundary conditions off just now, we can move the model to the side. We've got the ability to use this legend where we can modify the maximum and minimum. We can look at things like applying a maximum and minimum probe. We can also change the image from 6 colours, 12 colours or more. And we can use the deformed shapes and change the deformation as well. So you can look at the animation of the results. We can also do things like take bookmarks. So bookmarks are like snapshots. So like a snapshot of your result. Now, if you were going to be bringing in another version of the model, which we will do, we'll be able to see that the snapshots become quite a valued part of the process. So with the legend open, we can just go back into the results and we can look at a different set of results. If we wanted to look at von Mises, we can modify the legend. And the legend will show the results within the area. Now we're only working with 4 bolts there just now, so we're going to change that up. We're going to change that model and see how it looks. So we can also zoom into this area and maybe take another snapshot at that time, and we can get rid of the legend as well. Okay, so once we've done that and we've looked at how the results for displacement in, say, von Mises look, then the other thing that we can do is we can look at the nut and bolt resilient forces. Now, this table is something that you don't gain access to this information easily from most softwares. Now you can see here from the nuts, we've got the ability to see the information specifically around shear force, axial forces of each of the nuts, or sorry, bolts. So this information can be exported, it can be saved as a CSV and used at other stages of the process if need be. But the information is all gathered automatically So when the nuts, bolts are imported in with the geometry, they come in, they go into a category, that category is then analysed. And also the tightening that you've applied is also all in that process, and this is where the information comes from. The other thing that you can do in here is you can place in individual points. So if we go back to the bookmark, for instance, you can look at, looking at individual probed areas of the analysis. And that's why the bookmarks are really handy, because you can just jump straight back into the bookmark. You'll notice I didn't have to get into the results there. So you can see how quickly the results are gained through the bookmarks. So we can click on those. The other thing that we can take a look at is we can take a look at the reaction and contact forces. Now you can look at those individually per support, or you can look at them with connections. At a specific connection, you'll get the information on the total connected force and moment, which is really, again, quite handy, especially if you're looking at frames. If you've got a lot of frames that are attached to the ground, and you want to know a total amount of them, then you can use this dialog box, which will help you gain that information. So again, all of these icons down at the bottom here are all highlighted after you run the results, and you can view them in lots of different ways. Now, one of the things I want to quickly go over before we go back to the presentation is just how you import in another model. Now, let's say, for instance, your design has changed and you now have to go through a process of bringing the model in. You've done all the work with the structural, you've added the loads and constraints, and you want to bring in a model that looks slightly different from this one, and you want to analyse both designs together in the one interface. So with SimSolid, it couldn't be any easier. We just import in the model. Just to make you aware, the models can come from your CAD environment, where you step them out or push them out during different design iterations, and then you can import them into the software. Now, one thing that you'll notice about this dialog box is you're adding connections to new parts. This is not connections to the existing ones. This is just the ones that are coming in that weren't there before. And that's the same which applies to the material. So whenever you bring the assembly in, there are parts that may not have a material, and therefore you need to make sure that you apply parts to those that weren't in the original. It'll warn you if any problems come up, but yeah, it's intuitive enough to know. Now you can see that the geometry is slightly different. So if we look at design study 1, and then we look at design study number 2, you can see that the geometry is slightly different. Now we've got more nuts and bolts, so therefore we might need to modify our connection. So we're going to edit that, and we'll just get rid of the ones that are in there, and we'll select them again, and we'll click OK, and that will change that from highlighting in red to black, and then we can run the results on the structural too. And then again, we get a different set of results. And if we look at the bookmark, for instance, we can then just go to the results for number 1 and the results for number 2. Now that's again the reason why we use the bookmarks. So we can double check by clicking on these. We can go back to the magnitudes as well. Displacement, sorry. And we can see the difference between them. And then click on the bookmark again for our von Mises. And we're jumping in and out of the results. Now, all of that was real time, guys. I hope you got the gist of everything that we went over. I'm going to jump back into the presentation and just really quickly go over everything else that we need to do. I don't want to keep you any longer. I've just realised the time. So let's jump back into the presentation, go over everything. So just to reiterate over the results in seconds, not minutes, fully adaptable solution, powerful post-processing. So that's the process that we went over again, and we can take it from there. So let's let's just quickly run through some of the capabilities. So this is the portfolio of what SimSolid can produce. So we can see we've got structural, dynamic, thermal, and fatigue. And these are the types of capabilities. So we can see the solutions, modal, linear, statics, non-linear, the materials, connections, and results. Although I'm going over this quick, guys, afterwards we'll spend some time sending out the information. So we do have the NAFEMS report, which is available, and also a white paper that you can either download from the webinar now, or obviously if we have any discussions in the future, we can pass that information on to you as well. So in the interest of time, guys, I'm not going to go through this example just now. I'm just going to let you see some of the slides and the resultant time. But again, we spoke about, you've seen how quickly the analysis ran. But in the interest of time, you know, we can just go straight to the case studies and think about, this is Jaguar Land Rover. Now we've been working with Jaguar Land Rover, and Altair have been working with Jaguar Land Rover for such a long time. And they have been using SimSolid for such a long time. They also use a lot of the other Altair products in the HyperWorks range. So these are the types of results that they work, they actually see whenever they're working with SimSolid. So CAD results in 20 minutes in SimSolid versus 2 days in a conventional FE. These are significant results that we're seeing, big differences. And again, Renault, one of Altair's customers, SimSolid helps their designer to shape the chassis components with confidence based on the SimSolid solution. So guys, I know that was quite quick in the end. We do have a lot of data to send through. I think when we follow up with an email, we'll put these in there as well. But the 2 notifications that I've sent you through are the SimSolid product range, and there's a link to the theoretical background of SimSolid. It's a video, a 17-minute video about how SimSolid actually works. So I definitely recommend watching that video at some stage. So I'm just answering 1 or 2 of the questions that have came in. Peter, I've replied to yours. I think that one came up first on my list. Is gravity automatically assigned? It depends on, you know, if you can run just a gravity test on something, and they you would apply gravity to that if that was the case. Does non-linear analysis with non-linear contacts and material run as fast? Well, not completely, but obviously that's we still see results quicker when we're working with non-linear. But again, we do allow you to have, you know, a trial of the software so that you can run the software and find out, you know, if you wanted to push it to the limits during the trial, you would find out if it was capable of producing something within that time. But we do see the results quicker at times. Tom, I think you've got another question, but I'm not entirely sure what you mean by the translations of a specific point. Maybe I can fire you over an email afterwards, and we can go into that in a bit more detail. I think it's probably worth doing some email dialogue on that. Okay, guys, I've kept you a few minutes over. Does anyone else have any other questions? Fantastic. Thank you so much, everyone, for taking the time to answer the poll questions as well. We'll send out a follow-up email afterwards with the links and the handouts. I think the handouts are downloadable just now, so you should see the NAFEMS and the Altair white paper there as well. But we will be able to give you access to everything if you've got any queries afterwards as well. Okay, so thank you very much everyone for coming. Enjoy the rest of your day.